My name is Mayur. I'm software engineer at Collate, and today I'll be discussing about the lineage feature in depth, available in OpenMetadata. We will be focusing main on these three topics, that is automated lineage extraction, how we capture the lineage across different types of connectors in OpenMetadata. Then we'll take a look at how you can make use of lineage to do the end-to-end analysis. And finally, we'll be taking a look at all the features available on the OpenMetadata UI, which can help you consume the lineage in efficient way. But before jumping onto that, let us first understand what is lineage. So lineage is end-to-end flow of data, that is right from the absolute source to the absolute destination and everything in between. Uh, People often confuse data lineage with ER diagrams. But ER diagram just shows you how your tables are modeled within a database. Lineage gives you a bigger picture than that. Lineage uh, represents the flow of data across different tables, across databases, different types of connectors, and different services. With the help of Lineage, you can experience improved governance within your organization. You can implement better data practices for better efficient, for taking efficient decisions. Lineage also helps in root cause analysis. We will take a look at this when we discuss about the end-to-end lineage in open metadata. And finally, lineage gives you a better understanding of your data flows across different data infrastructures. Uh, so let's see how automated lineage works in open metadata. So every operation in open metadata happens via API, because open metadata is built on top of specifications and APIs. So similarly, to create lineage in open metadata, uh, we use lineage APIs. These lineage APIs are built on top of lineage specifications. So this lineage specification is designed in this way that it can connect any two assets available within open metadata and form the lineage. To give you one example, let's say I have a API endpoint, create user, that flows from that, it goes to a Kafka topic, and from that it goes to let's say a BigQuery table, and finally to a dashboard. So this way you can connect different types of services via the lineage. Since open metadata supports vast variety of data infrastructures, lineage specification and lineage API makes it very easier to create the lineage. Now, how do we automate the lineage extraction? So there are mainly three ways how we capture the automated lineage. First one is SQL query parsing. We have been developing a custom SQL query parser from past 3.5 years. Uh, this SQL query parser has been built on top of SQL lineage. Uh, we have got a lot of feedback from the community, with which we are continuously improving our query parser, and are also contributing to other open source projects like SQL Fluff and SQL Lineage, so that entire community can take advantage of this improvement. And another way of capturing lineage is intelligent parsing of dashboard service queries, or the API responses that we get from the dashboard, which gives us information about the data warehouses, databases, from which the dashboards or the pipelines extract the information from. And the final way is integrating right into the ETL tools like Airflow, dbt, Spark. We have been developing custom tools to integrate with this platform, so that your lineage experience gets better and we are able to capture the end-to-end lineage. So let us start with the exploring the database lineage extraction. So there are three ways we extract lineage from a database. First one is view lineage. So while you do metadata ingestion of any particular database in OpenMetadata, we also capture the schema definitions. These schema definitions are then passed to our custom SQL parser, and from that we compute the lineage for views. The next one is stored procedure. We recently introduced stored procedures as well, and we are also capturing the stored procedure lineage, similar to how we pass the view definition. We pass all the queries executed by a stored procedure and prepare a lineage between that. And finally, we also pass lineage via query analysis. Uh, Many databases maintains a history of queries executed on top of those databases. We extract that query history, perform the query analysis, and prepare lineage on top of that. So I have set up a Snowflake instance where I have executed the lineage and the metadata workflow. Let's quickly take a look at the metadata workflow and what are the different configuration available. So there are filters available here. So you can filter what types of what tables, what schemas you want to perform lineage on. And then there is query log duration. This query log duration helps us understand, helps you configure how many days of lineage you want to extract from the query history table, which will be used for parsing and using for lineage analysis. Then there is result limit, which shows how many queries for each day you want to extract to perform the lineage analysis. And then there are advanced filters available so that you can restrict your query set to perform analysis. For example, let's say I do not want to process lineage on queries which are generated from metabase, for example. So I can just paste a SQL condition like this over here, and it will ignore all the queries which are generated from metabase. And again, I we have recently implemented the multi-threading as well, which improves the performance of the lineage workflow and makes it run even faster. And this all information is extracted, as I mentioned, from a query history table. Now, suppose there is a database or a database connector which does not support maintaining the query history. In that case, you can prepare your own custom solution where you can maintain all the list of all the queries executed in a CSV file, and you can pass that CSV file as well in this configuration, and that CSV file will be used as the source for fetching the queries and performing the analysis. So it expands your scope of all the number of databases that we support for lineage. Now let's go to some tables and see the lineage in action. And let's start with a view. So I have a test view. We can see that the table type for this is view, and I also have a view definition available over here. We can see that this view was generated from test underscore table. And when I go to the lineage tab, I can see that a lineage getting created between the test table and the test view. And when I click on the edge, it gives me more information about this lineage. By default, it will give you source and target, that is the test table and test view. There is an option that you can also provide information about this lineage in detail. You can add a custom description. It also shows the transformation, or in this case, the view DDL, which was which resulted in this lineage, and finally the source of lineage, that is the view lineage. Now let's take a look at stored procedure lineage. So in this schema, I have to stored procedure. And when I click on the lineage test, I can see the DDL of the stored procedure. And we can see it is a insert statement. It is inserting into test table 2 and selecting from table test. So, and when I come to the lineage tab, I will again see the lineage between the test and the test table 2 created. And also the query which is associated. So again, when this query, when we extract this query from the query history table, we'll pass it to our SQL parser, which will indicate that the test table is the source of this lineage, and the target table is test underscore two table. And finally, we will make use of the lineage API and create lineage between these two tables in our OpenMetadata ingestion package using the Python SDK. And the final form of lineage is through the query analysis of the query history table. So for example, this is a CTS table. And when I come to the lineage tab, I can see that this table was created this way, that create table CTS as select star from test underscore Pablo. And while we capture the lineage, it is not only the table level lineage, but we also capture column level lineage as well. So when I click on layers and I click on columns, I can see that IND column is connected to the IND column of test CTS, and similarly, name is connected to name. So that was about the database lineage. There is another type which we support for databases, that is DBT, but we'll talk about that in the later section. Then we perform automated lineage extraction from the dashboards. So from the dashboards, we make use of either queries or the APIs that are available for each dashboard. We pass this information and try to interpret the lineage. So again, here I have a Tableau instance ingested, and in the ingestion section, I can see that I have performed a metadata ingestion for this one. And when I click on the edit button, I can see that I am passing DB service name as Redshift fraud, which I am aware that is the data source for the lineage. Now, Tableau itself will not give us a fully qualified name or a unique identifier of a table available in open metadata. That is why, to restrict the scope of search, you can specify whatever the data source is available for as the source of lineage for this one, and we can specify the service name. And while while doing this ingestion, the Tableau captures dashboards and data models. Data models are the one containing all the information about the different columns available. And when I come to the lineage section, I will see that this customer's data model is connected to customers table available in Redshift, which is the data source and the table. And finally, this data model was used for preparing a customer's report. And the column level lineage is not only restricted to the table to table lineage, but it is also supported from table to the data model lineage. So when I click on layers, click on the columns option, I can see all the column level lineage here as well. And the next type is pipeline lineage extraction. So similar to dashboard, we make use of APIs provided by these pipelines, or we integrate directly into the pipelines to extract the lineage information. So for a demo, I have my Airflow setup, and within Airflow, I have a sample lineage as a DAG. And we have built a custom plugin for Airflow, using which you can specify what are the source and the destination for a task available in the DAG. Now here you can specify the inlets and outlets, and it contains a fully qualified name of the data asset available within OpenMetadata. Those who are new to OpenMetadata, a fully qualified name is a unique identifier to identify an asset in OpenMetadata. So when I will ingest this Airflow instance in my open metadata, I will see the lineage getting created, and the same information that we have specified within this task gets reflected here as well. Now, this was an example of Airflow, but we also support the pipeline ingestion via APIs. For example, in the later part, we'll see how we extract lineage from 510. Uh, and finally, the Spark lineage. So consider you have Spark jobs running on your data infrastructure. To capture this information, we have developed a custom Spark agent which you can use to capture the Spark events, and then later interpret those events to create lineage in Open Metadata. To demonstrate this, I have a Databricks instance setup. Now, Databricks, we do support automated lineage extraction with Databricks, but there are some limitations to that. So to perform the automated lineage extraction, you have to either use a SQL warehouse, which maintains the log of all the queries which is required for lineage performed, uh, or you can use the Unity catalog, which maintains the lineage itself. But consider this scenario where I am using a compute instance, and I'm using legacy Databricks workflows. So here you can install the Open Metadata Spark agent jar, and whenever you are executing any query which qualifies for lineage using the same compute instance, that that lineage will get captured by Open Metadata automatically. So, for example, here you can see that we are inserting into table 4 and selecting from table 1 and table 2. So the same lineage gets captured in open metadata, and we can also see a Spark pipeline getting created, and the source, and it also captures the transformation query and the source of lineage as a Spark lineage. So these are the various types of lineage extraction, automated lineage extraction possible with open metadata. Now let's see how you can capture end-to-end lineage for your data architecture. To do this, I have prepared a small example. So consider I have an online application, uh, and let's say it is an e-commerce application. I'm using a Postgres as an online database for this application, which stores my live data. And then there is a 510 pipeline which extracts the data from Postgres and moves it to Redshift data warehouse. Within the data warehouse, I have three categories of table. The first one is raw tables, where the data from Postgres gets directly dumped onto these tables. And then I make use of dbt to perform transformation and aggregation. And dbt will be responsible for creating some staging table and final aggregated table that will be used at the end and get consumed by Tableau reports. So let's see how this lineage can get captured in open metadata. So I have this Redshift instance ingested, and I'll quickly go through all the ingestions available. So we have executed metadata lineage, dbt lineage, dbt workflow, lineage workflow, profiler workflow, and the usage workflow. Now, since we have not talked about dbt, let's just quickly go into that. So we can extract various types of metadata from dbt. That is, we can extract uh, documentation, ownership information, tags, and descriptions. Uh, but apart from that, we can also capture lineage using dbt. And our DB, you can either use manifest and catalog file for the dbt ingestion. You can either store it locally, you can store it on a and make it available as a HTTP endpoint, or you can store it in any of the object storage, or you can directly make use of dbt cloud as well. So once you have provided all the required credentials, in this case, I have to provide a manifest file and a catalog file. We will pass this manifest file and catalog file to extract the lineage information. So let's go to databases. When I click on databases, DBT Jaffel, and customers database is my final aggregated table. So I can already see that there are some staging tables and a aggregated table that is customer, which is connected to the customer's data model, which we previously saw in an example of dashboard lineage. Uh, but let's say I want to see the entire lineage. So I can just click on the settings. Instead of upstream and downstream depth being 1, I can just set it to 10 and click on OK, and I can see the entire lineage in a single view. So in this example, in the example that I just showed, we saw that we had some Postgres tables. So in this scenario, we have 3 Postgres table: orders, payments, and customers, which went into raw tables of Redshift via a 5 to 10 pipeline. Now, these raw tables then get transformed into a staging tables via dbt. So when I click on this edge, you can see the dbt transformation query and also the source of lineage as dbt lineage. And there are also icons here specified so that you can identify what are the nodes, what are the dbt models available in this lineage. And finally, this not only shows me a table level lineage similar to the other examples, it also gives me a column level view of the lineage. Now, this lineage information can get overwhelming if you have many number of nodes. Uh, so, for example, if I have here, let's say I'm interested in knowing what is the lineage for a particular table. So I can just click here, search for the payments table to see what is the lineage associated with payments table. So when I click on it, it will highlight the payments table itself, and it will also highlight the entire lineage of payments table right from where it starts to where it ends. This search feature is not only restricted to table, but it also allows you to search the columns. For example, let's say I want to view the payment method lineage. So when I click on this or search for it, it will highlight the column level lineage as well. Uh, okay. Now, let's assume you are a data scientist. One day you were taking a look at the customer's report and you found out that this report is broken. Uh, Now, if you didn't had this lineage view to identify what is the root cause of this breakage, you will have to go through various systems. That is, you'll have to validate Tableau, Redshift, dbt, and then finally 510 pipeline and Postgres to identify where is the actual problem to get it resolved. Now, within layers, we have this little tab for observability. When you click on that, it will show you all the test cases that are performed against each table. For example, for customers table, we had around 8 tests, and we can see 5 of them passed and 3 of them failed. Now, to get more information about this test failures, I can just click on the observability tab, and it will show me what are the exact tests that failed. So we can see there is a completeness test which got failed and a uniqueness test which failed as well. And interestingly, you can also see the from where it failed, it shows the highlighted lineage in red color, and the other lineage which got successful in a regular blue color. Uh, Finally, apart from filtering on basis of columns and tables, you can also do some advanced filtration on the basis of domains, owners, tags, and columns. Let's say I want to view all the data assets available within this lineage which are associated to sales domain. So I can just click on this domains filter, click on sales, and click on update, and it will show me the all the assets that are under the sales domain. So for example, the customer table is in sales domain, and so are all the assets that are displayed here. You can do similar filtration on basis of owners, tags, and columns. And it is also possible to filter on basis of tiers, services, and service type. Uh, and we also have this interesting feature for exporting the lineage. So let's say when I click on export button, it allows me to export and save the CSV file. When I open the CSV file, you can see all the information available within this graph has been presented in this CSV as well. This CSV file can be useful for impact analysis, manual validation of lineage. Uh, it contains all the information about domain, source tables, target table, or pipelines available within this lineage. Also, the column level lineage available. Uh, so this was about the end-to-end lineage. You can see it captures the lineage right from the source that was Postgres to the end that was my Tableau uh, database dashboard. Now, there are other catalogs, like one that came into comments as well, GCP Dataplex, and there are Unity catalog, Glue catalog. This also provide the support for lineage, but it has a restricted view. For example, let's say I have my Unity catalog available here, and when I go to the lineage tab, I can only see the lineage available within this environment, that is Databricks. Similar to that, AWS Glue will give you a lineage of all the assets that are available within the AWS ecosystem. But since OpenMetadata supports around 80 plus connectors, and this lineage can be captured automatically, OpenMetadata is in this unique position to capture the lineage right from the source to the destination, not worrying about if the connector is available within the environment that you're using. Uh, and finally, let's take a look at one of the most interesting feature on top of lineage, that is lineage propagation. So suppose I have this orders table. The data flows from orders to raw orders to STG orders, and the columns and the information available uh, are more or less the same. That is, the ID flows from one table to another. So the documentation related to this ID will also remain the same. Now, let's say I documented my source table and I want to propagate the same documentation to all the upstream nodes. I can just go to the governance, go to automations. Uh, okay, there is something wrong. Maybe I got logged out. Let me just quickly log in again. Yes. So here you can see I have a lineage automation created. And when I go to in details, I can see that I've created this automation uh, where I'm targeting all the tables available within my collate instance. And I have applied a filter that I want to perform this operation on on Snowflake service type. And within the actions, I've selected lineage propagation, and I have selected all these options available. That is, you can propagate description, glossary terms, owners, parent information, tags, tier information, and the same information at the column level as well. So it takes some time to run this automation, but for the sake of this demo, I have already executed it, and I can show you in my Snowflake instance. So in the beginning, we saw this view getting created from the test table. So when I go to this test table, you can see I have some description set at the column level as well. No tags as such. Uh, but since we have the description, the same description will get propagated to all the downstream nodes. So for example, when I go to test view, I can see the same description is available at the table level and also at the column level. If I had attached any tags or glossary terms, that would have got propagated as well. So that is how lineage automation can save efforts for repeated documentation. Uh, and makes your life easier. So far we discussed about uh, different types of lineage capture possible in open metadata, how API and UI supports the editing and updation of lineage. We also saw many filtering available in the UI, which makes it easier for you to consume the lineage. And finally, we also saw the lineage layers, uh, where you can see the data observability tab, the column level lineage, and we also had a look at the root cause analysis via the lineage. Now, these are all the features that are available right now, but let's see what is coming next. So in our roadmap, we have governance as a lineage layer. So similar to the data observability layer, will be introducing a governance layer which can help you with your governance workflow right in the lineage view. And currently, the lineage is available at, let's say, table level, but we plan to introduce the lineage at service level as well, so that in a single screen, you can see the entire lineage of all the tables and assets available within the same service. Then finally, we had a look at the lineage export functionality, but we plan to implement lineage import functionality as well, so that you can perform the bulk addition of or removal uh, right in a single click. We also saw stored procedure lineage, but currently it is limited to stored procedure written in a SQL language. We plan to increase the coverage for SQL, for stored procedure lineage and introduce different languages such as JavaScript as well. And finally, the last but not the least, feature that we plan to implement is automated removal of expired edges. We plan to we plan to you to configure expiry for different types of lineage. And once that expiry get passes, the lineage will get automatically removed. So that was about a brief summary of what all are the features available and what is in our roadmap. If you have any questions related to this, please let us know.